Hello. How is it going? How is it going, everybody? We are back with another live stream, and yeah, it's afternoon. I hope everybody's having a good weekend. And yeah, I had a very not hectic, but a little bit. Getting the light is too much here. So I had a pretty chill morning. Not that chill also. I had a couple of work at home, and then I said, okay. I just had my lunch, and I rested for a couple of. I think I rested for almost an hour, and then I thought, okay, what's next and what can we do? Okay, I thought, okay, I'll go around and chill with some food. I was thinking of playing a game, but then I thought, okay, let's actually look at maybe solve the LeetCode problem of the day first, and then we'll think of it. And as I started with that, I basically kind of started with a little bit of algorithm, and I thought, okay, let me just go ahead and stream it. That's pretty much it. Okay. Before that, I'm gonna quickly cross-check that everything is working fine, and there is no funny business with the mic and everything. So I'm just gonna mute my mic. Not that chill also. I had a couple of work at home, and then I said, okay, I just had my lunch, and I rested for a couple of. I think I rested for almost an hour, and then I thought, okay, what's next and what can we do? Okay, I thought, okay, I'll go around and chill with some food. I was thinking of playing a game, but then I thought, okay, let's actually look at. So I'm just gonna live test this mic and just see if everything is working fine or not. Okay, yeah. So I hope this is working fine now. Is working fine or not? Okay, yeah. So I hope this is working fine now. Is working fine or not? Okay, yeah. So I hope this is working fine now. Yeah, I guess this should be good now. Is working fine or not? Okay, yeah. So I hope this is working fine now. Working fine or not? Okay. Working fine or not? Okay. Hopefully now the voice is pretty clear and crisp. Hopefully now the voice is pretty clear and crisp. Hopefully now the voice is pretty clear and crisp. Hopefully now the voice is crisp. Hopefully. Hello. 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 Uh, hello. 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 Yeah, I'm just gonna keep this at defaults for now. I feel this is okay. Yeah. Good. Okay, I guess we are good now. And we get started. Okay, so welcome everyone. Welcome to another stream. It's hopefully going a good Saturday. And today, right now, for almost like for the next 1 hour or so, I'm just gonna be solving a little bit of algorithm problems. And yeah, that's basically the idea. I stumbled upon a couple of interesting problems, and I thought, okay, let me just solve it. And I thought, when I'm solving it, why not just simply stream? Honestly, streaming has kind of become like a fun thing to do. Yeah. But anyways, cool. So let's get started with it without any further delay. without any further delay, let's get started. Yes, okay, cool. So we were solving LeetCode problems, and for some reason I just thought, okay, let's do a filter on companies, and the first company which came to my mind was Oracle. The reason why it came to my mind because of the stock rise for the past 2 days or 1 day. So yeah, and I thought, okay, why not solve a couple of problems from here, right? Cool. So the first problem that I was solving is remove all adjacent duplicates in the string 2. You're given a string s and an integer k. K duplicate removal consists of choosing k adjacent and equal letters from s. Okay, adjacent and equal letters from s, and removing them, causing the left and right of the substring to concatenate together. We repeatedly make k duplicate removals on s until we no longer can, which basically means, so I was just trying to do a dry run in here. So let's actually do the dry run again. So you have d, bb, cc, e, something like that. So let's say in the first iteration, this is there, so this gets removed. Okay, so in the next iteration, this is there, so this gets removed. So what we can do to showcase this thing is this, I suppose. Yeah, so let's say this is removed. And then, yeah, so in that particular case now, CCC is together. So we remove that, then BBB is together, which is again 3 because the value of k is 3 in here, okay? So 3 adjacent ones, same letter, we remove that. So D is now this, so we remove this, and then we cannot further remove anything anymore. And we got AA as the answer, okay? It clearly says first delete triple E and CC. See, I mean, that is fine. You can delete it one iteration. I guess you you might save a bit of iterations there. Okay, you might save a bit of iterations there. So another question is, how do you solve this problem? One of the easier things to do actually is like we can iterate till like sort of a break condition happens. A break condition is when you cannot actually do that anymore. So maybe what you can do is you can iterate over and try and find substrings of 3 where the letters are the same. Okay, so you can kind of do a sliding window and try and find substrings of C, substrings, the same substrings of length K, and remove that chunk. The problem here is how do you efficiently remove it, and one of the ways to efficiently remove it is not working with strings and all of that, because then you would be more yeah. Okay, I'll go back to life. So what would happen here is that if you actually like use a string, it's gonna be really inefficient because we have to always create a new string. The second part of it is basically where I mean, we don't, so strings are immutable. Specifically, I'm using Java, so it's immutable. I'm not using C where we can just work with pointers. But strings below the C are nothing but pointers or like arrays of characters. So maybe we can do there, but still it's kind of inefficient because we have to shift around things within the array to concatenate. There are different ways to solve this problem, I believe. One of the things you can do is you can mark certain indexes dead or like not there in the string itself. So a soft delete sort of thing, but then you need some extra memory to, handle that. One thing, I mean, that can be a possible solution. I feel that can be a possible solution. The second thing that I'm looking for is one of the things that was coming to my mind here is like I mentioned here. So one of the things that we can do is a stack. Since we remove things from between and then whatever is there on the very end, it comes and appends, keeps on appending stuff. I feel stack is a good choice here. So one thing what you can do is you see D and then you say, okay, so like it's empty right now, so you're gonna just do D. Then it's E, so it's not the same as the top one, so you say E. Again, it's the same as top one. If it's same as top one, I want to see the count of it. So the count of it here is 1, right? And for this particular thing, we have to keep popping things out till it's E, and then, you know, do a count. Similarly, like, okay, so E, because it's 2, so it's not equal to 3, so you're gonna push everything back again. And then you have another E, which comes and says, oh, everything, if you pop out, then, you know, it's basically count as 3, so I don't have to push anything back. So whenever a new character comes in, if there is certain things in the stack till the stack is empty, or till the whatever data is at the top is same as this particular current character, you keep on popping things out, and you see if it has actually reached a count of k. If it has reached a count of k, you do not push anything back. If not, you push everything back along with whatever element you have here. Okay, so that is one thing. That is one thing, and yeah, basically that is the solution, I would say. And kind of looking at here, so the good thing about this platform is clearly says a constant, so the constant here is 10 to the power 5, and there is this thing which is time complexity with constraints. If I say there is a document which clearly says, kind of like a CP document, which clearly says that, okay, what kind of ranges you can go for different kind of these things, right? So if anybody is interested, this is the link. This is the link where if anybody is interested in this sort of thing, you can actually go and look up. Okay, maybe I put it also on. So I always forget time complexity with reference to constraints, but I feel that the main thing here, what I feel is that it's more like a guideline specifically for competitive programming. It doesn't give you the entire picture or the correct picture when it comes to actual real life algorithms. That's what I feel. That's what I feel, but it kind of gives a good benchmark. So as you can see, 10 to the power 5 we have, so we can go to len log n, and we are solving this in O of n solutions, so it should be a good solution. We use some extra space, but I cannot think of anything where we, you know, like can go below that. Okay. So one of the things that I want to do here is that it kind of becomes a tedious task where you have to keep on popping things out and then pushing things. So one of the things what I'm thinking to do is kind of an RLE solution. RLE, if anybody's interested, RLE encoding, run length encoding. Basically, what happens is that, so yeah, so let's say you want to encode this huge data, which is 4 A's, 3 B's, double C, something like that. So you just say 4A, 3B, things like that. So it has some kind of problems where you have numbers itself, but if you have simple characters which are not numbers, you can simply encode them with whatever the streak, run streak is for that. As you can see, this is original data, which is like whatever 10-15 characters, and then it got compressed. Whatever the number is, definitely short. So that is one thing which is yes. So that's basically it. And what I'm doing here is that, so instead of pushing each character, I'm going to say D1. Then I'm going to say E. So there is not E at the top, so I'm going to say E1. Now the second E comes in, I'm going to see that E is at the top. So I'm just going to add 1 to it. On the third one, I'm going to add 1 to it. Well, before adding 1, I can always check that if it's actually equal to K. If it's equal to K, I'm just going to pop up this entire string. So I'm compressing the amount of data that I'll be using. This kind of becomes a little bit easier in terms of also code that you write, because I believe I don't have to write a bunch of code. You have to write a while loop and all of those to, you know, keep on popping things out till it's the same. Till it doesn't come, the top becomes different than the character which is present here. But yeah, I mean, you hopefully get the idea. So let's actually solve this. Okay. How do I copy paste this stuff? So yeah, I'm just gonna copy the entire name as such. Okay. here itself. Oh, my bad. The music is off. That is why it's a little bit boring. I'm sorry. Winter Scar. Hey, hello, Winter Scar. Welcome to the stream. Welcome. How's your weekend going? Man, people have really cool names. There was I am Aries. I am Winter Scar. There was somebody called Cool something. Yeah, I just have my name. That's all. But really cool name, man. Winter Scar. Is that your hacker name? Is that your gaming name? What is it? I'm interested in knowing. Cool. So you basically have this thing which is yeah. So let's actually solve the problem. So you have a deck which needs a pair, which we don't have. So private record pair, and we can say character ch in frequency. That's pretty much it. So you have pair, stack this new array deck in character s.to character array, and then if stack is not empty, I'm simply gonna say wait, else stack push new pair ch1 gamer name. Nice. What games do you play? I play CS, but nowadays I have stopped playing CS because so I don't play competitive. I just play casual. But the problem nowadays is that, so one thing is, I don't think Valve give a shit about people, because every update, every 2 updates, the FPS drops. I feel really bad about that. The game has become a little bit more toxic, and like specifically all the servers are hopped by bots who are doing case farming and things like that. So I don't quite like it. By the way, I just want to quickly check here. Yeah, so yeah. Anyways, but other than that, I love COD. I used to play CS, Valorant, but not now. Yeah, I never played Valorant. It's too much stuff for me going on. So my brain cannot comprehend too much stuff at one time. And yeah, I used to love CS. I was a big fan of 1.6, and I used to play in a lot of LAN games in college days, which is way back, man. It's more than 10, 12, 15 years now when I used to play a lot of CS 1.6. And now still I play CS2, but I mostly play COD, but story mode. And recently I started Mafia, but I started Mafia from the very old one. And I recently completed the Hitman series, which again I started from the very beginning. But yeah, I don't stream games. It's just, I don't know. I just don't stream games. Anyways, yeah, nice to know. So why not playing games now? What, you're busy with something? Office, college, life? Okay, nice. By the way, no, I'm from Team Vikram. Okay. Team Vikram. Who plays games from Team Vikram? I'm not sure. So there are a couple of new people from Team Vikram who I haven't interacted with a lot. Because as far as I know, the people from Vikram, nobody plays games there. I know from my team people play games, but no one from Vikram. No one from Vikram for sure. And just like, are you one of the new folks? Are you one of the new folks? I think you're one of the new members of the team. Well, welcome to the stream, man. Thanks for joining. Thank you. Okay, before we get out of this, I want to quickly finish this off. So here is a new thing. So what I quickly want to do is, if stack peak, so this is safe because I know it's not empty, dot character is equal to this character. Man, I really don't want to do that. It's gonna be a lot of nested if else conditions, because then first I have to check if it's equal, then I have to check if it's this. So I want to do this thing here. So I'm just gonna say If it's equal, stack peak dot frequency plus plus. Wait, not frequency. What? Oh, I know what is the issue, because it's a record. I cannot do that because I changed stuff, right? So yeah. Private final character ch, but then private final int frequency. We cannot do this as final. And yeah, pair. Yeah, copy paste this thing. Awesome. This ch, this frequency. I am new joining. Yeah, I almost thought about it. I think, okay, cool. And how's your weekend going? I think I messed up my stream a little bit because I did low latency, ultra low latency today. And yeah, my internet is not able to cope up. I'm pretty damn sure about that. You need to change the resolution. It's not supported for this configuration. Can I change the resolution now is my question. So I just go to settings. Doesn't let me. Is the stream choppy is the big question. Why can't, what you're talking about, you cannot support 2K? Man, YouTube sometimes is very weird, and so is OBS on Linux, I feel. So let me just go on mute a second and see the video. Pressing the amount of data that I'll be using. This kind of becomes a plus plus. Wait, not frequency. What? I almost thought about plus plus. Wait, not frequency. What? Oh, I know what is the issue, because it's a record. I cannot do that because I changed stuff, right? So yeah. You know what, I'm just gonna keep continuing going through it, and that's pretty much it. I don't think so I can change my resolution right now. Okay, that's I suppose it's fine, I suppose. Okay, so you say frequency plus plus. So here you also say this, which means we can merge these two things together. So if it's not empty, you push the new character, and if it's not empty and the top is the same, that is when you do this. Stack peak dot frequency equal k. So if this is this, I simply say stack top, and this should be safe because of the fact we do this. So one thing we can do here is objects dot require not null. It will be not null for sure. Okay, that's fine. Next thing what we have to do is we have to kind of create the string back. We have to create the string back. So to create the string back, what I'm gonna do here is that I'm gonna just say that Okay, where is my Excali? Yeah, so this is my Excali right here. So it would be something like A2, but let's say there was B here, so it would be something like B1. So we have to go on the reverse direction. We have to go on the reverse direction. Yeah, I'm having a bad cold, man. I'm having a really bad cold, so this is for this. Okay. In here, what I can do, I suppose, is we accumulate things in a string buffer and we reverse it. I mean, what else can be done, right? So our string builder sb equals to string builder, while stack is empty, not empty. So I first do a pop. Where equals this. Then what I can simply do is speed.repeat. Can I do? I have to do code point and not count. How? You know what? Okay, so does it say what kind of characters we'll have? It only contains lower English case letters, so I'm simply gonna just say repeat pair.ch pair dot frequency and sb reverse. Does reverse send back? No. Reverse to string, and I suppose this is it. If repeat doesn't work as I expect it to, then we're gonna have a problem. Cool, we don't have a problem. So let's open chat. And software engineering, this thing in here. So let's give it notes. So Raquel, are you hiring me? I solved one of your problems. I'm kidding. Complete a challenge or okay. I already solved the problem of the day. Yeah, anyways. So here it is. So yeah. So here it is. I see what you're trying to implement. Okay. Why are you giving me Ram Katha, bro? Just give me notes. Removal adjustment. Use a stack, storing increment of pop when frequency reaches k. This is this. Okay. So I feel this is a good note. Okay. And now let's go ahead with the next one, pour water. Let's see if we can do that. As a matter of fact, I know this divide to integers I cannot do it because it's kind of a bitwise operation. Hate it. Anyways, okay, you're given an elevation map represented as integer heights, and heights of represents the height of the terrain at index I. The width at each index is 1. You're also given two integers, volume and k. Volume units of water will fall at index k. Water first drops at index k and rest on the top. What? You're given two integers, volume and k. Volume or units of water will fall at index k. Sorry. Water first drops at index k and rests on top of the highest terrain or water at that index. Then it flows according to the following rules. If the droplet would eventually fall by moving left and then move left. Otherwise, if the droplet would eventually fall by moving right, then move right. Otherwise, rise to its current position. fucking didn't mean anything. Here, eventually fall means the droplet will eventually be at a lower level in a direction that moves. Also, level means the height. Okay, we can assume there is infinity height range on two sides of the bounds of the array, so that no partial water could spread out, or okay. And each unit of water has to be exactly one block. Okay. So this is this, and okay, so 4 volumes of water drop at 3. So it drops at 3. So this is already height of 2. So it drops at 3, it becomes 5. The first drop of water lands at k equals 3. When moving left or right, the water can only move to the same level or a lower level. Yes, by level we mean the total length of the total height of the terrain plus any water in that column. Since moving left will eventually make it fall, it moves left. But it can also fall. A droplet made to fall means go to a lower height than it was previously. Since moving left will not make it fall, it stays in place. What the fuck you're talking about, dude? So you get some water here, but how much? Okay, so only 2 units of water would go here, because you have 3 units of water. 2 units of water would go here, and 1 unit of water would go here. So what are you asking? What is the question, buddy? How much every unit has water? Is that what the question is? So this has 2 units of water, this has 2. No, the levels, final levels, okay. So 4 units of water fell through. Acha, because only 2 units can go on the side. This seems like a really jackass problem. I don't want to solve it. Okay. Okay, the droplet would eventually fall by moving to the left, then move left. Otherwise, if the droplet would eventually fall by moving right, then move right. Otherwise, rise to the current position. Yeah, basically it means that if it cannot drop on either side, it would just keep there, and that is what the level is. Okay. So it doesn't quite anyways say given 2 units of water fall. Okay. Eventually means that droplet is resting. We can also assume there is this. Also, there could be no partial water. It still doesn't say what is the answer that they require. Question. आ गया क्या बोलो? Okay. This guy talks a lot about like a lot of word, but nothing they have built. But I mean, that's what sells, right? On talking shit. Anyways, I'm just talking about a guy who bring me for something. Yeah, okay. So now, yeah, I'm really not in the mood to solve this, honestly. Fuck you. What I want to do is, I want to do some... What can I do? Let's do some interview question, I guess. No, I cannot do that on my ID and stuff like that. So... yeah, let's see what Walmart is asking. Let's see what my company is asking. Why not? Why not? Oh, sort colors, text justification, minimum time difference. I saw all three of those. But text justification, I feel, is a really, really tough thing to solve. It's fucking tough, man. So if I just say all, oh, I solved almost 61 of them, but I just solved the others, which I really do want. Sort. Let's see. Say a bunch actually. Okay, divisor game. I had to do normal latency right here. Take it. That's fine. Alice and Bob takes turns playing a game, while with Alice starting first. This is important. Initially, there's a number n on the chalkboard. On each player's turn, the player makes a move consisting of choosing any value of x within 1 to n minus 1, and okay, so you have to choose something which is divisible, replacing the number on the chalkboard with this thing. Okay, so if there's 4, you choose a number 1 or 2 which can divide 4, and then you would just replace. If a player cannot make a move, they lose the game. Return true if and only if Alice wins the game, assuming both players are playing optically. Okay, this is a jackass question. I again hate these kind of questions where skipping stones, and I think these kind of questions where you were given a bunch of sequences. Basically, I feel it's a more game simulation. Yeah, it's more a game simulation, and trying to just find that trick where you catch a hook and say, oh, this is a number that I want to reach to, and just backtrack it. This is usually how this goes through. So as an example 2, so Alice chooses 1, Bob has no more moves, because if you yeah. Okay, so see, I feel you have to reach 1, because from 0 to 1 there is nothing that you can select. So you have to, whoever is there, whatever number you're subtracting, would have to reach 1, and to reach that particular number there is only one pair, which is 2 and 1, which means that whoever has 2 wins. Whoever has 3 loses. So if you're at 4, you can basically be like 4 minus 1 and just go to 3, because whoever can reach 3 would be the one to lose. The other person would win. Okay. Oh. Okay. So here, what I can do is 4 minus. So what happens if I am 5? So the only value I have is 1, so I can simply do 1 minus 4. And if I go to 4, there are a couple of options, but the bigger problem is I don't want them to reach at 4, because if you reach at 4, you would usually throw a 3 at me. You would easily throw a 3 at me. No. So yeah, so I have to bring them down to 3, because if I do 3 minus 1 is 2, and if you give me 2, only thing I can select is 1. Yeah, if I could bring the opponent down to 3, that should be the game changer. That's the only thing I have to do. Oh man, I should have probably slept a little bit longer, but okay. So 1, 2. So if I'm at 1, I'm a loss. If I'm at 2, I'm a win. If I'm at 3, I'm a loss. If I'm a 4, it completely depends on how I can do it, but I think we can easily do this as a loss, because I can force somebody to come here. What if I'm at 5? So if I'm at 5, I can only do 1. So if I do 1, that means it's gonna be 4. So I give opponent the 4, we can easily throw me back at 3, and that is a win. That's a loss, right? Lost 1. So what about 6? If I'm at 6, so 2 and 3, I can easily throw them at 3. And if I'm at 7, then the only choice I have is 1. So I throw them at 6. They will throw me back at 2. Sorry, 3. To make me lose. So I feel the answer can probably be something like this. If I have an even number, I can win. Let's see. Yeah, that's basically it. So divisor game is a very simple solution. That's pretty much it. Can you, by the way, cool. While it generates, I'll quickly go and respond to this guy. Okay. That's all. Cool. What's next? Count nodes with highest score. Okay. There's a binary tree rooted at 0, consisting of n nodes. The nodes are labeled from 0 to -1. It's already 4:40. Just give me a second. I will be back. I'll quickly take a 5 minutes break. Also need to refill my water, so I'll quickly take a 5 minutes break and be back. Yeah.
It's gonna be hard to do. Doesn't matter. It doesn't matter because what happens is
Okay, we are back. But I don't think you guys are here to see me. But yeah, I am just gonna switch over to my screen. I hope you're here to see that, not my face, right? Cool. Okay, going back to the problem statement. Count the nodes with the highest score. There's a binary tree rooted at 0, consisting of n nodes. The nodes are labeled n-0 to n-1. You're given a 0 index integer array parents representing the tree. The parents of I is the parent node of I. Since node 0, it is -1. Okay. So each node has a score. To find the score, consider if the node and the edges. To find the score of a node, consider if the node and the edges connected to it were removed. The tree would become one or more empty subtrees. The size of the subtree is the number of nodes in it. The score of the node is a product of the sizes of all the subtrees. What does it mean? Okay, so if I remove 0, so I remove these two, then the product itself would be, then the score itself would be 3 into 1. So the score would be 1. So the score of node 0 is 1. So if I remove it, what is the same, right? Okay, cool. And if I removed 1, if I removed 1, okay. Binary tree rooted at this thing. Okay, so return the number of nodes that have the highest score. Okay, so 3, 4, because if you remove 3, the other entire tree would be the subtree for itself. Okay. Well, in any particular case, a particular node, if I remove it, the maximum number of subtrees that I can have is 3, because one would go away from the parent, one would go away from the left, one would go away from the right. So those are the 3 edges that you can have with a binary tree. It says a binary tree, right? Yeah, it's a binary tree. So at max, you can have 3 subtrees. At max, you can have 3 subtrees. Okay, cool. The question is, if I remove one thing, what I do have to find is, what is the number of nodes from that particular subtree? All right. That node. Because, so let's say I remove 0 here. I remove 0 here. So if I knew that 2 has 3 nodes together in its entire subtree, so I can say, oh, this is this, and for 4, this is this. The main question is what happens when I remove 2. So if I remove 2, I would have to get the number of subtrees for 3, for 1, for 0, and for number of nodes for 0. But there's a slight problem here. I just cannot do that. I feel what I have to do here is that, because, so let's just do another level. So it is 0, 2, 4, 1, 3, 0, 2, 4, 1, and 3, 3, 1. Let's consider a couple of more nodes, which is 5 and 6. So 5, 6, 7. So if I look at the number of nodes at each one of the levels, this is gonna be 1. This is gonna be 1. This is gonna be this is gonna be 2. This is gonna be, well, it's not 2. It's 3. Here it's gonna be 4. Here it's gonna be 1. Here it's gonna be 4 plus 1 plus 1, so 6. This is gonna be 1. This is gonna be 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is correct. So maths is correct. It checks out. Right. Now the question here is that, given if I remove 5, I just cannot simply say what is the root node, what is the number of nodes. So I can always look for in the children, but I cannot look for in the parent, because if I cut this out, this here would be it. So I cannot simply say it's 4. But what I can do is I can say it's 8 minus whatever is here, which is 5. So for left, you have the number of nodes. For right, you have the number of nodes. But you have for the parent, it has to be root minus the current node. That's what we have. But here specifically, the array is given and not the tree itself is given, right? So we have to, like, the easiest way I feel is you have to generate the tree. But I have a feeling that since you already, okay, so let's look at the constraints. So the constraint is 10 to the power 5, which means n log n is something that we can achieve. It represents a binary tree. Parents 0 less than for I not equal 0. If it's 0, it has to be minus 1. And so y equal, it would have just said less than. Yeah, I guess, don't know. And in here, it's basically saying, okay, the number of nodes together can be 10 to the power 5, which means that we can still go up to a solution of n log n. So let's think about this a little bit. So let's take an example here. Let's take an example. The parents is this. So 0, 1, 0, 1, 2, 3, 4. Okay, so we have 4 nodes in here, and so we can start from here and we can look at 2. So 2 is a pair. 2 is my parent. So I look at 2. I look at 2. This is this. So I can just say total is 1, 2, 3, 4, 5. So 5 will be the number of nodes at the root level, right? This is for guaranteed. This is definitely guaranteed, right? So now what I can simply do here is that I can say, hey, take this and so I guess till you reach a point, you do this. So this would be minus 1, this would be minus 1, this would be minus 1, this would be minus 1. So let's actually do for this one, right? So let's delete all this stuff. Okay, so there are 8 nodes. 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7. So for 0, it's minus 1. The node 1 is having parent 2. The node 2 is having parent 0. 3 is having 2. 4 is having 0. 5 is having 3. 6 is having 5, 7 is having 5. So this is what it's 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. This here, everything would be -1. Okay, everything would be -1. So let's just consider it's -1 or 0. We can consider 0 also. So it makes sense. It cannot be 0 ever. Right, it cannot be 0 ever. So what I can simply do here is that I can say that if you are taking, so what we were doing, we were just trying to figure out through the parent path, at some point we'll reach 0, right? At some point which will reach 0. So one of the things I believe we can do is we can do the parent graph. Yeah, we can find out, let's find out who's 0, right? So anybody who's 0, anybody's having parent as 0. No, that is not something we can do. Okay, so anyways, so this is parent is 2. So if I just go with that particular intuition, it cannot be, I cannot still figure out the answer for this. So I have to start at the root nodes, I mean leaf nodes. So that's an interesting point. How can we do that? We can simply go over the array and we can say whatever values are not there are leaf nodes. So 0 is there, 1 is not there, 2 is there, 3 is there, 4 is not there, 5 is there, 6 is not there, 7 is not there. So these are your leaf nodes from which we can actually start working, right? From which you can actually start working. I close it. Yeah. Okay. So in here, I can simply say that. So if I start from all of these, if I go to 1, so 1 is here, which I can say 1, and then there's 4, 2, 3, 4, 5, 6, 7. So I say every one of these. The next we want the ones which are like the parents of these things. We want to go to them. But the parents of these things will also have a dependency on something else. So that is kind of because I can have only one left child, but then I can have 3 right children, which means that I have to, recursively go up the tree in that way. I'm just wondering, should I just build a tree? I'm just trying to figure out a solution where I don't have to build a tree. I feel if I build a tree, it's gonna be a lot more simpler. Because then I can simply say what's the parent, and since I'm building the tree, I'm gonna keep a pointer to who's this thing. So maybe let's first do let's first give it a little bit thought about this, okay? And yeah, 10, 5, which means again, like I mentioned, it's probably something in terms of n log n that we have to achieve, which will give a guarantee that it's going good. Yeah. Okay, yeah. Okay, just give me a second. I'll quickly be back here. Okay, we are back. It's Saturday, right? So a lot of work at home. Anyways, someone's giving me a smile. That's good. Nah, that's cool. Sorry. Cool. Where is this thing in here? Yeah, I'm just trying to figure out a way if we don't have to do that, because I feel if I did this thing, it's gonna be very, very simple where I can simply say, oh, yeah. But anyways, so one thing what I quickly want to do here is I feel we have a child to parent relationship. We probably have to generate a relationship on the other way to see. Yeah, I'm not quite sure. I still don't see the hints yet. Still don't want to see that yet. Is it lo-fi? Yeah, it's lo-fi. So I'm not quite sure which also there is lo-fi songs, but I do not want to play it because of copyright stuff. But let's see. I have to make a playlist of what things I can play, what things I cannot. But okay. Anyways, so what do I do here? What do I exactly do here? I need to know the number of nodes for sure. I need to know the number of nodes. I feel we have to build a tree, but 10 to the power 5 is a huge number to build a tree. Honestly, I feel 10 to the power 5 is a. So let's look at one hint. You need to find the sizes of the subtrees rooted in each of its children. Maybe DFS. Yes. The question is, how do I do the DFS? How to determine the number in the rest of the tree? Can you subtract the size of... Dude, again, it just told me the two things that I already figured out. Okay, it's not here, but I already figured out what is the solution. But I need to find out, like, I need to think of a thing here which tells me that how exactly I find out the number of nodes at a certain node, right? In that particular subtree, if I say. That's the question. That's the question. You know what? Maybe we can start from 0 and go down the tree. We can start from 0 and go down the tree as a DFS. And so we'll say everything is 1. The number of children at every node has to be 1, correct? And from 0, okay, let's delete this crap. So I start from 0. The question is, which branch do I need to go? So I need to find 2 nodes which are this thing. So I feel we can create a map where it just says, okay, this is a parent, and then you have 0 is to 2 and 4, 1 is to nothing, 2 is 2 is to 1 and 3, 3 is a parent to 5, 4 is a parent to something. So something like that. I feel if we do that, then I can start from 0 and I can say, okay, go down to 1. So what is 1? 1 doesn't have anything, so I'm just gonna return back 1 from the recursive solution. I'm just gonna return back 1 and add it to the number of nodes thing. Right? I add it back. So what I'm saying here is, so let's quickly copy paste this stuff. Okay, so 0 is the parent of 0, 1, 2, 3, 4, 5, 6, 7. So 2 and 4, 1, 2, 3, 4, 5, 6, 7. So 1 is the parent to nothing, 2 is the parent to 1 and 3, 3 is the parent to only 5, 4 is the parent to nothing, 5 is the parent to 6, 6 is the parent to nothing, 7 is the parent to nothing. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So everything is 1 in the beginning, right? So everything is 1 in the beginning because that has to be the number of nodes of 1. Okay. The next thing that we want to do here is we want to say, okay, start from 0 and do a DFS. So from 0, we would say, okay, go down to 2 and 4. So I'm gonna do a post order thing. So once I start coming back is when I'm gonna return back the answers. So it goes to 2 and 4. So first, let's say it went to 2. From 2 it went to, so let's keep this track. So from here to 2, from 2 it went to 1, and from 1 it's a stop. So 1 returns back as 1. And since it's a terminal node, I don't do anything here. We have to figure that out. Okay, so we return back this. So for 2, what is the solution? Before we take the solution for this, 2 had 2 children, so it would also branch out to 3. So 3 would go to 5, 5 would go to 6, 6 would go to nothing. So this would give back as 1. So 5 is only having 1 branch, so it's gonna be returning back 2. Sorry, it's gonna be returning back 2. Then from 2, it's gonna be returning back. 5 is gonna return back 2. For 3, it's only 1 branch, so it's gonna be returning back 3. So for 2 here itself, it's gonna be 1 plus 3 plus 1, so it's gonna be sorry, how much? 5. Is that correct? So for 2, we saw it's 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Yeah, that is correct. I just have to figure out how to manage this array. That's all I need to figure out. And that, I feel, should be the solution. Okay, so let's copy this. And let's say... Okay, maybe here we can also put in the Okay. So the first thing what we did was we created a map, right? So let's do that. Private map in teacher, list of integer, import class, generate tree. So in here I would be taking in parents or int I equals 0. So let's call it n n less than parents dot length. Sorry, n plus plus map integer list of integer tree, this new hash map. Okay, so now what do we do? We can simply say parents, wait a second, so int parent is equal to parents of I, n. So let's call this node. Yeah. Okay. So now I'm gonna simply say if tree dot contains the parent, then I'm gonna say tree dot get the parent and add the node. Well, we can do it in the other way. Tree dot put parent new array list, and we can very simply say this is always gonna be 2, maximum of 2. Okay, so tree dot get the node, well, parent dot add the node and return the parent, return the tree. This is what we will be doing. So generate tree, you get the parents, map integer list integer is this thing. Well, plus I have given it this. So this is this. So what do we do then? We have to create this part, right? So int node count is new int parents dot length. So one thing I'm not quite sure how I'm gonna do the DFS. I'm gonna do the DFS in this way. Private int private void calculate node count at. So we will have a current node. We'll have the integer list of integer tree and node count, something like that. So if tree dot get node contains key is not equal to is not equal to this thing. So node count of node is equals 1, and we have to return 1, suppose. Otherwise, what you can simply do is tree.get node. So we can iterate over this and call this child. So what I have to do is calculate node count at child tree node count. Yeah. Next thing I know, int node count is 0, 1. Count is 1. So this is this, and then return count, but here node count at the node level is gonna be equal to 1. I believe that's what it is. And then we call this function, and here this is 0, this is the tree, this is node count, and you call this function, that's all. So now we have to keep looking at what things we have to do, the thing that we actually discussed in the beginning, that what we are going to do when you have a certain yeah, by the way, okay, my screen is visible. For a moment I thought I am just sharing my OBS. It's not right. Yeah, I just switched. Okay, cool. So here what we have to do is we have to go over this place where if I remove 0 I have to find 3 links. I need to find the child, and I need to find the parent. Question is, there's also a question if there is a parent, right? Does there there will always be a parent except 0. Sorry, except 0, because it's a binary tree and not a graph. There'll always be a parent sorry, this thing. So what we have to do here is, so let's say if I am removing 3 in here, I can simply say who's the parent of 3. It's 2. I don't need that. I actually don't need that. I can simply say this is 8 minus 4. 1 2 3 4. Yeah. So for parent I actually wrote it, which went away. So for left we take it from the array, for right we take it from the array, and for the parent stuff we simply say root minus current. Sorry, root minus current. That is what the solution is. So we also need integer frequency score map is new hash map. Sorry, and in here I'm just gonna let it resize. Honestly, just gonna let it resize. All right, I'm just gonna let it resize. Then what I'm gonna simply do here is I'm gonna say that we are iterating from 0 to the same. So for I int n equals, so let's call it node equals 0, node less than length, node plus plus. Okay, so instead of length we can also call this as nodes. It's fine, length is fine, I suppose. So we can simply say key if node equals 0, I am gonna say tree dot, so let's do this, tree dot get node for let's call this child. So in here I'm gonna say So since the maximum, okay, so we are also doing multiplication, so we have to be a little bit careful. But since the maximum is 10 to the power 5 that you can go, so once you divide, it's gonna be less. You cannot go anything over. Yeah, it won't overflow. Basically, that is what it is. It won't overflow. So if I go here and if I say, sorry, if I go here and if I say child dot, sorry, what we have to say. So can I just cast to an int right away? Yes. So we take the node count and child. So this is what it is, and int score equals 1. This is this. Sorry. This is basically what I'm looking at. Then if node not equal to minus 0, this is when we look for the parent stuff, right? This is where we look for the parent stuff. So I'm going to simply say parents of node. You get that pre dot get node, and my bad, node count of 0 minus node count of node score this thing is equal to this. Now I can simply say dot put compute, this is the score, and you take the key, you take the value, and you say if value is null, you push in 1, else you just increment it. Okay, and what exactly is the question here? The highest score is 2 and 2 nodes have the highest score, so the answer is 2. Return the number of nodes that have the highest score. Okay. Int max score is 0. Int max int count equals 0. For map entry, integer, let's just say e, and score map dot entry set. So if e dot get key is greater than max score, max score should be e dot get thing. So let's call this as score. Let's not do this cast. Let's do this, and then here I'm gonna say count equals e dot get value. Return count. The problem here is we do a lot of casting and uncasting, like boxing and unboxing happening there, which I feel is a little bit slow on the virtual machine, and it actually takes a toll on your performance. And I will make a video on that someday. Awesome. Map.get is null. Where did you have this issue? Okay, so let's actually debug this shit. New count nodes with this thing. What is the name of the function? Oh, it's right here. Okay. I understand this. Yeah, I understand this. So if tree dot contains key, no, this is when we'll do this kind of thing. Yeah, this is when we'll do this kind of thing. Otherwise, we don't want. Cool. Yeah, this was a miss on my end, but I think now it's okay. So if tree dot contains key node, cool. Let me submit and hopefully see that it looks fine. Didn't work. Awesome. Awesome. Output is 17. You expected 1. This is a huge number, I suppose. So let's use this. And you know, one of the things we can do here is not do this. So let's just say it's a tree map, and it's a tree map comparator of comparator dot reverse order, but what if they are same? Can we compare it to the, okay, not quite sure. Comparator dot values. So sorry, tree map, do we have anything? Doesn't seem we have anything. So yeah, so what we can do here is we can simply say before everything system out print ln scroll map, right? So we can log that and see exactly what's happening. So you have this, okay. It feels like overflow can happen. It feels like overflow can happen. So what we can simply do is, this is long, this is long, and this is long, long, long. So maybe this actually solves the problem. Not quite sure, but let's try it. Okay, class solution. Ah, that was the problem. Okay. But it's slow. And if I analyze the complexity, still will be O of n time complexity. But if I look at the space complexity, this is also O of n. People have been doing better, and let's look at one of the solutions here. So they, I am guessing, actually jumped the tree. Okay. So list and size of the subtree is n minus total. Total is basically your like the number of nodes itself. Let's ask ChatGPT what it thinks about it. Can we optimize this solution, or a better solution exists? So you just go over the entire thing in here, which is A, okay. Who writes program like this, man? Oh, max group count and all of that. Okay. still don't have a response from.
I remember my dreams.
Can you do something? ChatGPT, the day I started paying it less, it just sucks so much, honestly. It sucks so much. It's slow. It's ridiculously slow in my opinion. It's built in React, right? Yeah, of course it's built with React. Okay. I'm gonna move forward for now. I'm gonna visit this back later on. Two further houses of different colors. Okay. Short answer, yes. You can make it both simpler and faster in practice by avoiding map boxing. Yes, okay. Using primitive arrays and array lists for the tree. The algorithmic complexity stays same, but the constant factors drops significantly. Building adjacency as this thing instead of map avoids boxing and overhead. Okay, this is kind of, but even still here you would be boxing stuff, right? The fuck? So do not use a map to collect all the scores. Instead, compute each node score and maintain a max score and count on the fly. This avoids creating many map entries during. How will you figure out that I saw something before? Yep. Use long and treat the complement component carefully. Multiply math.max 1 and minus so you don't zero out the product when component size is 0. Why will component size be 0? I don't do component size 0. Keep everything primitive and long to minimize allocations and GC. Yes. When removing a node, okay, you build the adjacency list instead of this thing, so it's primitive friendly. How is it primitive friendly? Let's be precise here. Okay. Key unboxing keys are integer boxed. Every time you do a key that contains, the primitive int is auto boxed as an integer. Okay. So here you can, okay, so from that perspective it does. Okay, that makes sense. That makes sense. And we can also do quick lookups. We can also do quick lookups, right? Multiply size of the rest of the tree if present, tree to 0 as 1. Okay. If score is greater than I'm not getting this. The question is, does this run or did it just fucking hallucinate? Does this run or did it just hallucinate? Oh, it runs. And if I run the code, it's way faster. Wow. So here, what did it do? Every time you do a DFS, DFS combat solve, fill the subtree count around first, okay, that's fine. If complement n minus this thing, if complement is greater than 0. Okay, so why can't you just keep it 1 in here? And then if score is greater than max score, then max score is score, count is 1, else if this, okay. But what if you find a map? That makes sense. That kind of makes sense. So I want to do this little change here where I don't go over this. If score is greater than max score, max score is equal to score, count is equal to 1, else count plus plus, else if score equal to max score, then this is this. And we don't need this, let's nuke it. And let's also nuke this thing in here. So if I copy this and class solution, this is where it should be like a little bit faster, I suppose. It's still slow. So I'm guessing the maximum amount of, like, if I actually do some sort of a flame grafting, this is a function which gets called more. Yeah. That's also probably a good exercise. Try and do flame graphs. Anyways, let's go to the next question, which is there are n houses evenly lined up and each house is beautifully painted. You are given a 0 index array colors of length n, where colors I represents the color of the ith house. Return the maximum distance between two houses with different colors. The distance between is absolutely okay. Okay, the maximum difference between these two here is with two different colors. Okay, two different colors. Okay. So you have 1 1 1 6 1 1 1. So it's either of the two. Let's think the furthest two houses are 0 and 3. Okay. Let's look at some of the constraints. The constraint is pretty less 100. So test data generated at least two houses of different colors. Okay. Sorry. So for this thing, I feel what we can do here is, if I just refresh, how many did I solve? I solved 63 of these. Okay, cool. So I want to take this example in here. Where, so what I want to do here is simple. If I just simplify the question, it's basically I want to find two different numbers farthest in the array which are different. That's pretty much it that I want to do. And since it's only 100, I don't have a problem doing n-square solutions. So I can keep a pointer here and I can say what's the, and I can, like, you know, iterate from this side and say what is the first value? What is the first value which is not the same as this? So if it had 1, it would have come. So this is what I'm going to do. Okay. build parent child relationship. So this is where I have to put in the notes. Yeah, so let's try and solve this. Yeah, we already decided this, right? Max distance equals 0. For int I equals 0, I less of colors for length, I plus plus. For int g equals colors length minus 1, and extract this out. G should be greater than I, and G minus minus in here. Yeah. If array, not array, colors of I not equal to colors of J, J minus I. So here itself, 0, 1, 2, 3, 4, 4 minus 0 would be the job. Math dot max distance, this thing, and we assign it back to max distance. And we can simply break and go to the output loop and return max distance. That should be pretty much it for this problem. Should be pretty much it. Is there another easy one? It's already 5:50, so I'm guessing at 6 o'clock I'll stop the stream, and technically I would be streaming for almost 1.5 hours almost. Oh, it's almost more than 1.5 hours. It's 2 hours now. So yeah, and then I'll be going out for some time, having some family time, but then I'll be back again in the evening, maybe 9 o'clock. I'll stream again, where I'll be streaming the full stack application that I've been working on. Okay, so coming to the point where it's let's do the easy part first. Split the array. I don't know if it's gonna be easy. You're given an integer nums of even length. You have to split the array into 2 parts such that what? Okay, nums1 should contain distinct elements, nums2 should also contain distinct elements. Return true if it's possible to split the array. Return true if it's possible to split the array, and false otherwise. Well, I think this is gonna be a very simple thing. Thankfully I picked it up because I quickly wanna go. So what does it say? Optimize insiders. Max distance not involve either the first house or the last house. Why? Okay, that makes sense. So furthest J where this thing, furthest I where. Cool. Okay. Anyways, let's go back to the split array problem. So a split array is simple, where the first question is you have to split where the length is equal, which means int length equal nums length. Okay, so if length is this, we can simply return false. That's all. We didn't have to check that, but okay. The second thing, so there are only 100 elements again, so I guess that's why it is a simple problem. So one of the things I have to check is frequency. Frequency map compute num, and then the key and the value, and then here if value is null you say this plus 1. If frequency map dot get num is greater than 2, return false. Otherwise I feel you can do it. I may be wrong there, but yeah. Cool, that works. And yeah, basically that. So can you give me the notes? So we have solved almost, I think, 4 or 5 problems of visa. Check if the array can be split. Okay, step 1 of the array, then return false, build frequency. Yeah. We did quite a good amount. I have no idea what I saw. Anyways, yeah. Feels like a good time to stop now. It's almost 6 o'clock. I'm planning to go out a little bit, have some fun, spend a little time with my wife, and then come back. So if I'm back early, I'm hoping to be back early, and at 9 o'clock or 8:30, I will be starting a new stream where I'll be, you know, I will be working with Vault IQ. So this is the GitHub link. If anybody is interested, I'm leaving it on the comment. I'm just gonna pin it for now. So yeah, so if anybody is interested, if anybody is interested, we have the GitHub link there right at the pinned comments, I mean on the chat itself, and I'll leave it in the description also. I think it's there in the description. Yeah, it's there in the description also. You can find it in the description. And yeah, I think if you guys are interested to join my Discord channel, there's a link right here in the description. Do join the Discord channel. I'm not giving the link right now because I don't want to open Discord. Maybe I can. So let me just stop sharing my screen for a moment. So yeah, so if you actually join Discord, it becomes a lot more easier to send out notifications, and we can connect, and we'll try to build a community which is which can be used for software engineering, for learning, but most importantly, software engineering for fun is what I am planning for, where it's not just grinding something, but doing something because we can do it. Okay. So that's something that I'm thinking about. And yeah, if you're interested in those kind of things, please join the Discord channel that I've given. Oh, wow. Yeah. So that is pretty good. Winterscar has joined. Thank you, Winterscar, for joining. Oh, I never actually went inside my channel. I'm really sorry for that, but yeah. Yeah. Come and join the Discord channel if you want to get updates. I will be creating Discord channels and things like that, which, you know, kind of becomes easier for everybody to connect. And I'm trying to build a community where we are more interested in software engineering rather than just you know, just cracking some interview, is my opinion. So yeah, that being said, thank you so much for everybody who joined. I had a good stream. I don't know how many problems I solved, but I solved a couple of them. I was anyways solving a couple of problems before I even started streaming, so on stream I think I solved 4 of those problems. And I just chose LeetCode today randomly, and I chose Visa because that's where I work, and I thought, okay, let me see if I can solve those problems. Apparently I can only solve how do I do? Oh, I don't want that right away. So I still have like, yeah, my number of hard problems are less, so I have to still work on that. And protect your streak. What do you mean protect your streak? I just finished. But yeah, if I go here, today I didn't. Oh, contest is tomorrow, right? So at 8 o'clock. I'll try to actually do that. I don't know if I'll be streaming that or not, because in the morning my face is all, and honestly I am never in the mood to do anything in the morning, so I have doubts whether I'll actually stream in the morning or not. But yeah, well, whatever. So now coming to the main point, yeah, so I have solved a little bit less hard problems, and I feel I have to go and solve a couple of hard problems to start having that traction in data science, data structures and algorithms, and have that command. And I'm hoping so that the contest rate and things like that can improve over time. So yeah, so it improved from 1698 to 1712, which is quite good, I would say. Then okay, drop down again, whatever. Probably have to. I probably want to go at 750, 1800s. Okay, yeah. And in any case, you can visit my channel. You can visit my website. I do blog, and I am. I do blog in the sense 2024, 1 year back was the last blog that I posted, and I'm trying to be more regular right now. So I have to balance out a lot of things. But yeah, I'll be definitely more regular. Okay. So saying that, thank you so much for joining. Sorry. Thank you so much for joining, and hope you had a good day. And yeah, I'm guessing we'll catch up again at around 9ish. If I don't have anything else, I will be joining. I will be streaming. Okay. Yeah, that's the plan. So let's see. So thank you so much. Thank you everybody who joined. Thank you for being part of this. And I had a good learning session. I hope you guys had some fun and learned something new. Thank you so much. Stay tuned. Bye bye.